let's think for a minute about why this ellipse ended up bigger than this one. That's not too difficult to see from the equation, because as z gets bigger, we know that if we're looking at planes parallel to the xy plane, if z is some constant number that's getting bigger and bigger, then we're going to have a bigger and bigger number subtracted from the left side of this equation, from the 4x squared plus 9y squared. When we put this into standard form, we're going to end up adding this number to both sides so that the right-hand side of the equation will become larger. So, for example, when z was 0, the right-hand side of this equation was 36. So when we divided through, we divided by 36, and these numbers came out accordingly. When we had z equals 10, this number became 136. And of course, we calculated these numbers by, again, dividing accordingly. It should be clear that the bigger z gets, the bigger these numbers are going to get. So that these ellipses, as we move higher and higher, are going to continue to grow. What's that going to do to the shape of our surface? We don't want to complicate this picture any more than we already have, but we can visualize higher and higher planes containing bigger and bigger ellipses so that our surface starts down in the xy plane and expands, and in the xz plane starts here and expands. Another thing we can observe is that if z is a negative number, if z was negative 10, that would not have made any difference down here because we're squaring z. We would still end up with negative 100 here, 136 here. So if we were to, again, we don't want to because we don't want to mess up the figure any more than it already is, but if we were to come down to z equals negative 10, draw an auxiliary set of x and y axes, we would end up with the same size ellipse that we did in the z equals plus 10 plane, so that this surface is getting narrower, then getting wider. As we come down to the xy plane, it reaches its narrow point, its waist, and then below the xy plane it starts to expand again. And it does that all the way around. It's always wider in this direction than it is in this direction, and the rectangle is always similar. The rectangles in which we draw the ellipses will always, now I'm gonna yeah, they'll always be similar, because whatever number we divide by here, it's the same for both. So we'll go on in a minute and try to discover a little bit more about this surface.